Okay, so first off, we need to remember triangles and the sum of the inside of triangles. What does the inside of triangles have to equal?
180.
180. Okay, so on this, we had ones where we created shapes out of triangles. So like when we had this, I don't know, trying to connect here. Okay, so we have a pentagon here. So if I wanted to figure out how many triangles are in this, remember we chose a vertex and then we drew to all the other vertexes. Well, there's already one drawn to that one, right? So then I would draw to here, and then I would draw to here, okay? So I could figure out what the sum of the inside of that shape is by doing what?
Adding all the like triangles up, waiting for the 180s.
Okay, so we could do it that way, or there was a formula. Do you remember the formula?
Isn't it sides minus 2 times 180?
Yeah.
Dang. I'm writing your name on the board. Somebody's getting excited. It's not an easy one to remember. Okay, so n minus 2, which is the sides, right? N minus 2 times 180. So if this was a 5-sided figure, and I subtract 2, that gives me 3, and then I multiply it times 180. So that's one way you can do it. The other way is just knowing I have triangles, I have 3 of them, so 3 times 180. Okay, and there's drawings that are on here. Okay, and remember these are multiple choice. So if you like do it and you're like, it's none of those, then you've done something wrong. Let's go back and look at it. Okay. Okay. How about this one? So you can retain this: x squared minus 9x plus 18, and I want to factor. I'm going to break that apart. Yep.
You split the x's up into two, like you split it up into 2 separate parentheses.
Okay.
With the x's on each side.
Okay.
On each side, and then the minus on the 9 indicates that it's.
What are my signs going to be?
It's both negative.
Both negative. Okay.
And then you find a factor 9 that's.
Not a factor of 9.
I'm sorry, factor of 18. I didn't need to say 9, I mean 18 to add.
Okay, so a factor of 18 that adds to equal 9. So we read it backwards, right? Okay, so factors of 18 that add to give me 9.
Negative 6 and negative 3.
Okay, and it doesn't matter where it's from?
Yeah.
Okay. So the nice thing about this one, again, this is going to be multiple choice. Okay, so you might see 3 and 6, but one's positive, one's a negative. What would be a way that I could check it if I had my answer up there? Just distribute it back to see if you can get back to the original, right? Okay, so that's going to be on this. If I know sides of right triangles, okay, if I know the sides of these, what formula can I use to prove that it is a right triangle?
Isn't it a squared plus a b squared?
Right. A squared plus b squared equals c squared. So if they give you a number, say they gave you 3, 3, and 5, right? And 5 is always going to be the hypotenuse because that's your longest side. Okay, if I squared this, so that would be 9, squared this, which is 9, what do I do with those two? Add them. So 9 and 9 would make 18. Okay, if I square that, that's what? 25. Would this be a right triangle? No. Okay, so on here they give you like they'll give you like the 3 numbers. They'll say 3. They don't draw the right triangle because they're wanting you to say, is it a right triangle? Okay, so an example that they have on here, it says how many of these triples, which is just the 3 sides, how many of these triples could be a right triangle? So you just do what we just did there. Square it, add it, does it equal square of the other one? Did it work? Yes or no? Well, there's 1, which that one didn't. And you're just saying how many of those work. Okay? So that's what they're looking for on that, to prove that it's a right triangle. Okay? Okay, here's another one. So the length of one of the legs of a right triangle is 7. So that we already know it's a right triangle. So one of the legs is 7. The hypotenuse is 12, so that's your C. And they want you to find the length of the leg of the other one. Square. Oh, what? Say it again. You're right. Okay, so she's subtracting. Why is she subtracting?
Because whatever's left over is the answer.
Right.
They need to
Because
add
these
the
two were, right, these two were supposed to add to equal this one, so when you don't know it, right, we're still squaring it, we're still squaring it, we're still squaring it, but I can't add them. When I square this, I'm going to subtract them, okay? So some of these are perfect squares, some of them will be radicals, okay? So simplifying the radical. How do I know when we're doing, so like that 18 and 25, that's a good example because it's not the one that's this next one, but they give you three numbers and they want to know is it a right triangle, an acute triangle, or an obtuse triangle? How do we find that? We just said we know how we found right triangle, right? Because we just said we square this, and if it equals this, it's a right triangle. How do I know when it's acute or obtuse?
Isn't it when the hypotenuse is larger, it's obtuse?
Right.
If it's smaller, it's acute.
Right. So this one that we did here, this would not have been a right triangle, right? Because the C was bigger. So if the C is bigger, then that would have meant this is an obtuse triangle, right? If it was flipped and say we squared it, and this was my C, and this was my A and my B, then it would mean it's what? It's acute. So another way to think about it is when you've got a right triangle, we know what that looks like. But when you have this side that gets bigger, it has to push this out, which makes it obtuse, right? But when this gets smaller, it pushes this guy in, okay, to make your triangle. So that's what makes it acute, okay? So if the C is bigger, it's obtuse. If the C is smaller, it's acute. And then if it's equal, then it's right. What's that page? Okay, what equation is standard form? Without looking at the board.
It's like the equation solves it, or it's
There we go. So the x and the y are together, okay? So one of them on here wants you to write it in standard form, and when you're looking at the multiple choice, they have them like written with the y by itself, with the x and the y together, okay, and then everything moved to the other side, okay. So there's some of just the recent stuff that you had on here. Okay, segment addition postulate. Okay, they said let D be between E and F. Okay, this is a segment, so we know segments are straight. Okay, so D is someplace in between E and F. Okay, and they say the distance from ED, okay, is 6Z minus 15. From D to F is 5Z minus 18. And then EF, so the total distance, is 33. And they want you to solve for X. And this is called segment addition postulate.
You'll add both of those and put them equal to 30.
Okay. So these two, right, should add to equal the total. Okay, well, I don't know what they are, the length of it, but I know I'm supposed to add it. So this would be 6Z minus 15 plus the other segment, which is 5Z minus 18, and then I set it equal to 33. And then from there, just solve your X. So and it says on here, segment addition postulate. So you just need to know which two you're adding, right? Okay, so drawing will help you. One more like that, and then I think we'll stop and pause and breathe. That's Monday. Okay, it's another segment addition postulate, and they've got A here, B here, C here. They put 16 here, and then they said AC is 28. Solve for AB. Subtract, right? Okay, so we don't know what the missing one is. Okay, but I know that the two, A, B, and B, C, are supposed to add, so you would do the opposite of what we just had on the other one. Okay, I'm gonna pause it. So the rest are kind of like beginning of semester stuff. And we'll go over some of that stuff tomorrow. Okay, so far, hopefully you're retaining that stuff. That's the whole idea behind EOC. Okay, chill for the next episode. Sing it, Brody.